The question is, a file system with 300 gigabytes disk uses a file descriptor with 8 direct block addresses, 1 indirect block address and 1 doubly indirect block address. The size of each disk block is 128 bytes and the size of each disk block address is 8 bytes. The maximum possible file size in this file system is option A 3 kilobytes, option B 35 kilobytes, option C 280 kilobytes, option D dependent on size of the disk. So it is given that the size of each disk block is 128 bytes and the size of each disk block address is 8 bytes. So the number of addresses in a disk block, number of addresses is equal to 128, which is the total size of the disk, divided by 8, which is the size of one disk block address. So it will be 128 by 8, which is 16. So now this is the total number of addresses possible. Now it is given that the file descriptor has 8 direct block addresses, 1 indirect block address and 1 doubly indirect block addresses. So we need to find the maximum possible size of a file. So these 8 direct block addresses contribute to 8 into 128 bytes. Each disk block is 128 bytes. These are the 8 direct block addresses. So 8 into 128. Then there is 1 indirect block address. An indirect block address is, there is a block with 16 addresses. Each address points to another block. So with one block you can basically point to 16 other blocks. So the one indirect block address will be 16 into 128, because as I said, one block has 16 times 16 different addresses. Each of this can point to one block. So totally 16 blocks. Each block is 128 kilobytes. So it is 16 into 128. Next is one doubly indirect block. So this is, each of these 16 blocks basically points to 16 other blocks. So you will have 16 blocks here. Each of this will point to another block. So that will be 16 into 16 into 128. So this is 8 into 128 will be 1024. This is 2048. This is 32,768. So if you add these three up, it is 35,840, which is 35 kilobytes. So the maximum file size in this file system is 35 kilobytes. So option B is the right answer.